What is Chebyshev's inequality? In this video, we will try to understand that. Let's say we have a sample and we know the mean and the standard deviation of the data. Chebyshev's inequality helps us in getting more insight into the data. As per the Chebyshev's inequality, if x is a random variable with a finite expected mean value mu and a finite non-zero variance sigma square, then probability the absolute value of x minus mu greater than equal to k sigma is less than equal to 1 by k square, where k is greater than 1. So, after some calculation, we can say probability the absolute value of x minus mu is less than k sigma is greater than 1 minus 1 by k square. In other words, we can say if k is a positive real number greater than 1, then as per the Chebyshev's inequality, 1 minus 1 by k square part of the data from a sample must fall within k standard deviations from the mean of the data. Now, if k is equal to 2, then 1 minus 1 by k square is equal to 3 by 4 is equal to 75%. So, 75% of data from a sample must fall within 2 standard deviations from the mean. Similarly, if k is equal to 3, then 1 minus 1 by k square is equal to 88.88%. So, 88.88% of data from a sample must fall within 3 standard deviations from the mean. Now, let's look at an example. Let's say x is a random variable that indicates the number of people coming to a restaurant in a day. Let's also assume that the expected value of x is 10 and the standard deviation is 2, and we want to know the probability that the number of people coming to the restaurant in a day is between 6 and 14. Now, in our previous video, we discussed z-scores in statistics. We discussed that z-scores in statistics describe the relationship between a value and the mean of the data that is being observed. For example, if the z-score of a value is k, then that will mean the value is k standard deviations away from the mean of the data being observed. Interested viewers who want to know more about z-scores, please refer to our previous video on z-scores. The relevant link is provided in the description. Now, we know that the z-score of a value can be calculated using the following formula. Z-score of x is equal to x minus mu by sigma, where mu is the mean and sigma is the standard deviation of the data. Now, in our example, the z-score of 6 is 6 minus mu by sigma, that is minus 2, and the z-score of 14 is 14 minus mu by sigma, that is 2. So, the data points 6 and 14 are 2 standard deviations away from the mean. 6 is less than the mean and 14 is more than the mean. And as per the Chebyshev's inequality, if k is a positive real number greater than 1, then 1 minus 1 by k square part of the data from the sample must fall within k standard deviations from the mean. So, if we put k is equal to 2, then 1 minus 1 by k square is equal to 3 by 4 is equal to 75%. So, 75% of data from the sample must fall within 2 standard deviations from the mean. In other words, the probability that the number of customers coming in the restaurant in a day is between 6 and 14 is 75%. Therefore, there is a 75% probability that 6 to 14 customers will come to the restaurant in a day. I hope this helps. Interested viewers who want to know more, please refer to the playlist Statistics for Machine Learning or visit the website of the Security Buddy. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.